Hello yet again, everyone. This is Bob Martin with the Nautilus Drydocks, and we are continuing our saga, the construction of this 177 scale Disney Nautilus model kit conversion to RC operation. If you've been following along, you'll see there's 4 other chapters that you've missed if you haven't seen this one before. And they cover all of the aspects of the construction of this model to make it functional. This particular one is going to focus on trimming the boat out for a surfaced and submerged operation. We're going to get this thing in the water, try and get it ballasted correctly, and see how it performs. So thanks for joining me. Let's get started. All right, here is an overview of the boat before we get into the trimming operations. You see I got the lower hull in place, I've got the watertight cylinder in place, all of my linkages are connected, my main drive shaft is connected. I got the upper hull here with the LED lighting lead, and I have installed 5 pieces of flotation foam in the hull. Now this is standard construction styrofoam. It's closed cell, typically comes in 4x8 sheets, but if you go to your local hardware store you can probably get what they call a handy panel. It's 2 feet by 4 feet. I like the 1-inch pieces unless you've got a big model, in which case you can get the 2-inch thick slabs. Cuts really easy with a sharp hobby knife or utility knife. The installation in this particular model, when you lift up the lower hull, you'll find that this is about where the center of balance is, right behind the salon area. There's no ballast in the hull right now to counteract anything. What I've got in the top then is the flotation foam centered about the salon area, and then to counteract that additional weight in the back, I've installed a big block right here. Now when you install all of this, you need to take careful attention of how everything is going to line up. So this block right here is going to sit in this open area behind. You'll see I've created a trench in the center and 2 openings here for the hoses and for the main drive shaft. If you take a look from the top, you'll see the profile of the foam that you need to cut. It's going to be an arced shape, just like that. Then flat on the inside edge, and because this is perfectly in the center, you can take measurements off of here to cut your foam. This was installed with 3M 2-sided automotive tape. You can also use silicone, which I actually did for this rear section here to make sure that it stays down. Now that I've got all of this here and installed, what I am actually going to do is put just a little bit of weight in the bow of the boat, likely just underneath the battery compartment. And then we're going to throw this into the test pool and see how it sits. If we need to add more foam, take foam out, add ballast, etc. All right, everyone, as you can see, we have the Nautilus in our test tank. What I am doing, because I want this to be ballasted slightly positively when the ballast tank is full, I have opened up the ballast servo, turned off the power, and that's left it open. So the tank is completely full of water at this point. So this is basically submerged trim, and as you can see, it's not very submerged. I will show you the placement of all my ballast and foam here shortly, but what you want to do at this point is add some weights in the hull to bring it down so that just the wheelhouse is exposed. So what I'm going to do, I'm just going to set some weights on the hull until it gets to the proper ballasted state, and then I'm going to put those in the hull and double check it again. All right, I am going to consider this what I think to be perfectly ballasted for submerged trim. The deck is completely awash. There's about 1 inch or 1.5 inches of the wheelhouse sticking out. It's on an even keel, and that is the weight and the placement that I'm going to need to put in the hull in order to get that ballasted and trimmed properly. So the big thing to note with this, you want to make sure all of your ballast is very, very low in the hull and all of your foam very, very high. With such a powerful little propeller on this boat, when that thing kicks on hard, this model is really going to want to roll. It's called torque-induced roll, so it'll twist off to the side like this as that propeller torques up. And the way to rectify that is to put your weight low, your foam high, and create a lot of static stability in the model. So I'm going to mount that ballast in there, and then we will get on to some actual functional dive tests with the ballast system. Alright, we are set up for the the final testing. You'll see I got one more addition to the model. The last thing that needed to be done was to fabricate an extension to the snorkel. Now, of course, the reason for this is that when in submerged mode, the deck is basically submerged and there's no way for the ballast system to draw air. So we need an extension, some way for the system to draw air from above the water line. There's a few different ways of doing it. You know, you could run something from the top of the wheelhouse there, and in the past I've also run something up the dorsal, but this is completely removable, and it just slips over the top there so that when the ballast system draws air, it'll draw it from above the surface of the water. So with that done, let's go to our fancy test tank, drop it in the water, and see how all of our careful ballasting worked. Okay, here we are in the test tool. We got our test tub, and we've got our LED lights on. A little hard to see in the bright daylight like this, but prop seems to be working really, really well. I can move it back and forth quite easily, and there's not a lot of that torque-induced roll that we were talking about earlier there. So full surfaced trim, and this is just about right for the Nautilus. You can see that the waterline comes up right in line with the bottom of the skiff, which means you can actually launch it. Let's zoom in there so you can actually see where that works out to. So that's a very realistic surfaced trim. Let's vent the tank. There you go. Now there is a little bit of surface tension on that flat upper deck. You just kind of break that a little bit, and there you go. We drop down to where we wanted to be. So that's submerged trim. And with just a little bit of forward movement, you'll find that you'll be able to dive this boat really easily. When we get this in the water, out in the open water, we'll get into the performance characteristics of the Nautilus and some of the quirks that she has. But that's submerged trim. Let's get up to surface trim. Turn on the pump. And there we go, full surfaced trim, and that didn't take long at all. So, with the exception of fabricating the rudder extension, this boat is ready for her maiden voyage. Alright, as I mentioned, one of the last things that we need to do here is fabricate our clear rudder extension. And what I have here is a chunk of clear plastic. And I got this just off of some food packaging that I had in my recycle bin. You don't want anything too thin, so like acetate, clear acetate is probably not going to work. But yeah, raid your recycle bin. Find some clear plastic, something with a little bit of rigidity to it. And all you need to do for this part is just mark out the height of your rudder. And then you're going to want to cut a piece out about an inch or an inch and a quarter. You can contour it, you can round it, you can make it look nice, you can express your creativity on that. The cool thing is once that's underwater, you'll never see it, and once you're out, simply pulling it back takes it out. So I'm going to cut this to shape, and I'll show you how we get that inserted. Alright, here is my completed clear rudder extension, and you can see I've basically tripled the size of my rudder and certainly from a distance you can't see it, and even close up it's really hard to see. And this is just friction fit, so you can pop that out there for display when you are not operating it, and then to install it you simply slip it into the slot, press it into shape, and you're set to go. So just use some scissors, trying to follow the same kind of contour and shapes as the back of the hull there, and you're done. This will basically double your effective turning ability on this model. I highly recommend it. Alright, let's take a look at the final placement of all of the flotation and ballast in the boat. Starting with the flotation, again, this was the foam section that I had carved out. I showed that to you earlier. Fits in the section right here between this wall and the trailing edge of the watertight cylinder. We have pieces approximately 1 inch in length, and this is running exactly the length of the cylinder. You can see, well, as we put it in right like that, you can see how that would fit in there. That leading edge matches up right there. You've got 2.5 inches of length in the back before we start our foam lengths. They run all the way up here, and then we've got a chunk of 1 inch thick foam by approximately 2 inches in this forward section right here. For ballast, these are quarter ounce weights, and these are all chromed and everything, so they'll never rust or corrode. And if we count them up, we've got 2, 4, 6, 8, 10, 12, 14, 16, 18, 24, 26, 28, 30, 32, 34, 36 of these individual quarter ounce weights in there, and that is the orientation and placement of the ballast. So this is the particular setup that worked perfectly for my boat. Yours is going to be different, I guarantee it, but this will get you started if you want to start out at what I've done here. So as you can see, the boat was trimmed out just about perfectly. It was exceptionally easy to drive, and actually what I ended up doing was disconnecting the automatic pitch controller. Under full acceleration, any minute vibration will sometimes set those pitch controllers to go a little bit crazy, and it'll get them to shake. I found simply disconnecting it worked really well. The boat was so easy to drive that it really didn't require that automatic pitch controller. So it's still in there, but I think for the most part I'm just going to leave it disconnected. One thing to consider, if full static diving is something that you're after, it's very easy to do after the case. Now, what we sell is something called a gas backup system, and that replaces that pressure canister in the ballast tank with a pressure vessel for liquid air. And that allows you to have a full gas ballast system. You can still retain the pump system, but the gas will allow you to get fully under the water where you can rise to the surface again statically. And it's rather inexpensive. It's about $75 and just a few minutes to install. So that's something certainly to keep in mind as well. This is set up more for safety's sake, but it was really enjoyable to drive. It took very little forward momentum to get that boat to pull under. And one thing to note, the design of the Nautilus is such that under full speed surface, it's going to want to pull itself under the surface of the water all on its own with no steering input whatsoever. And I've seen that evident both in these smaller models and up to the big 5.5 foot Nautilus models. So just keep that in mind as a performance characteristic of this remarkable boat. There you go, everyone. I'm going to say that this Odyssey is now complete. Thank you very much for joining me, getting this 1/77 scale Disney Nautilus complete and ready for RC operation. Hopefully this cleared up any of the questions that you had and how these models are put together, and gave you some of the confidence to undertake that task yourself. If you have any questions or comments, by all means email me at any time at bob@rc-sub.com. We'll see if we can talk you through getting your very own Nautilus in the water. So thanks again for joining me. We'll catch you next time.